Hello students, today we are continuing our understanding of equations with addition and subtraction. So looking at our notes for today, in the first box it says quickly review the rules for integer operations to apply them to solving equations. Rewrite any subtraction problems in order to add the opposite. That is important, add the opposite. So when working with equations, you're going to be using a lot of positive and negative numbers, so it's really important to know and remember your operations with integers, which are your positive and negative numbers. And we're also going to be working with fractions and decimals as well, so rational numbers will be included in this. Now, for our first couple problems here, this is considered a subtraction problem, so just to get into the habit of it, I would like for you guys to go ahead and rewrite that subtraction problem as an addition problem by adding its opposite. So this would really become 9 plus a negative 14, okay, so that we understand what's going on with our positive 9 and our negative 14. This is how we're able to get our answer and take away from a negative number. Now, if I was to solve this problem, if I have 9 and I spend 14, okay, that means that I spent more than I had. So that means that my answer is definitely going to be a negative. And in order to find this solution, I would find the difference between these two numbers. Now, I know the difference between 9 and 14 is 5, because if I count up from 9 to 14, 9, 10, 11, 12, 13, 14, if I use my fingers, the difference between those two numbers is 5. So if I had $9 and I spent 14 of it, I spent more than I had, I went into the negative $5. For the next one, I've got negative 9 minus 14. Again, I'm going to go ahead and rewrite this subtraction problem as adding the opposite of the second number. Okay, that's a negative number plus another negative number. So that means, here's your scenario, I borrowed $9 and then the next day I had to borrow another $14. So I am still in the negative, and I'm just going to add those numbers up because they have the same sign. So I know 14 plus 9 is negative 23, and that would be my solution to that problem. Okay, for the third one, I've got negative 9 plus a negative 14. We just did that a moment ago, same type of problem. So that would be negative 23 as well. And then this one is negative 9 plus 14, very similar to our first problem. Okay, but the signs are a little bit different. So this means that I owed someone $9 and then maybe I paid them $4. So my answer is definitely going to be positive because I have more positive numbers than I do negative. And the difference between the 14 and 9 is 5. Okay. So again, we're going to review how to solve algebraic equations. Number 1 is you need to isolate the variable using inverse operations. Okay, so for that would be like if you're subtracting, you're going to add. If you are adding, you're going to subtract. You're using the inverse operations. You're doing the opposite operation. Number 2 means you're going to solve by keeping the equation balanced. So whatever you do on one side of your equation, you have to do on the other side. And then number 3 would be to check your solution. So plug your answer back into your equation. So now I'm going to look at problem number 1. Okay, I have x plus 4 equals a negative 11. So I know I want to isolate my variable. That's the goal number 1. So that means that I need to get rid of this positive 4 that's with it. And if I have 4, if I want to get rid of it, I'm going to take away 4, making my variable all alone. That's 0. And whatever I do on one side of my equation, I have to do on the other. Now, if I have a negative 11 and I'm taking away 4, okay, that would look like negative 11 minus 4, which means I need to add the opposite because I'm technically subtracting right now, right? So I'm going to change this to addition and change this to a negative 4, which is really negative 11 plus a negative 4, giving me a total of negative 15. Okay. Now, because my x equals negative 15, I'm going to check my solution. So instead of x, I'm going to plug in negative 15 plus 4 equals 11. And I'm going to make sure, or negative 11, to make sure that that works. If I have negative 15 and I add a positive 4 to it, okay, that means I'm going back towards the positives. I would end up exactly at negative 11 because my positives and negatives cancel out. Again, if you ever get confused about how to add positive and negative numbers together, just think about it in terms of money. That always seems to make the most sense to me. If you owe someone $15 and you only pay them $4, you still owe them those $11. So you're still in the negative 11. Okay, and then on your graph, just go ahead and put a negative 11 here for me so that I know that you know where a solution would go on a number line. Okay, moving on to question number 2. We've got x minus 3 equals a negative 12. Now, again, I want to isolate my variables. So if I want to get x by itself, I'm going to get rid of my minus 3, which means I have to add 3 to it. Drop my x. Okay, a negative 3 plus 3 puts you right at 0. So x is by itself, and whatever I do on one side of my equation, I have to do on the other. So I'm going to add 3 over here. Okay, if I'm at negative 12 and I add a positive 3 to it, that's like owing someone $12 and only paying them $3 back. Okay, so we're still going to be in our negatives. And 12 minus 3, finding the difference between those two numbers would be 9. So therefore x equals negative 9. If I plug in my value for that, negative 9 minus 3 equals negative 12. Remember, you always have to add the opposite when you're subtracting negative numbers or positive and negative numbers. So negative 9, change to addition. You're adding the opposite of positive 3, which is negative 3, equals, I know negative 9 plus negative 3 equals negative 12. Because those signs are the same of my negative 9 and my negative 3. And I can add those numbers up, giving me a total of negative 12. Okay, moving on to question number 3. Now, whenever I see a problem like this, I always like to rewrite it so that my variable is on the left-hand side. So I'm going to rewrite this equation as x plus 8 equals negative 32. Okay. Now, if I want to get my variable all by itself so that I know what x equals, I'm going to get rid of the number that's with it, which is my positive 8. If I have 8 and I want to get rid of 8, I'm going to subtract 8. And drop my variable down. Whatever I do on one side of my equation, I have to do on the other. So I'm going to subtract 8 over here. Remember, this is negative 32 minus 8. When that happens, you got to change to addition and make this the opposite sign of what it was before. So positive 8 would become a negative 8. Negative 32 plus another negative 8 is going to get you a grand total of negative 40. So x should equal negative 40. Now I'm going to check my answer for that. If I have negative 40 and I add 8 to that, okay, that would be like owing someone $40 and only paying them 8. You're still owing them $32. The difference between 40 and 8 is 32. And last but not least, let's go ahead and do this one together. And then we'll have you do the last two on your own. I'm going to rewrite this problem so that my variable's on the left-hand side. So this would become x plus negative 5 equals 17. Okay. Now I'm going to try and isolate my variable. So that means that I am going to get rid of my negative 5. And in order to get rid of negative 5, that means I have to add 5 to put it back at 0, because negative 5 plus 5 equals 0. Now my x is all by itself. And whatever I do on one side of the variable, I have to do on the other. So I need to add 5 over here as well. And I know that 17 plus 5 is 22. So x equals 22. And now I'm going to check my answer. Instead of x, I have 22 plus a negative 5 equals 17. If I have $22 and I spend $5, I would have $17 left. Okay. What I want y'all to do at this time is try and solve the last two problems all by yourself. You can pause the video for a minute, and then I want you to go on to the next portion of your notes. We're going to do those together, but I want you to solve 5 and 6 by yourself first.